this project, again, I know it's frozen, but my video's not frozen, just the projector. So, I need you to read the prompt and, of course, do the annotating to understand what's happening. So Kate is at it again. At her daycare center, she needs to make yet another toy box to hold building blocks at her daycare center. In order to lower the cost of making the toy box, she needs to use the least amount of material possible. The box will have a square base, but must have a volume of 32 inches cubed. She does not know if she can afford a closed box or if she can only afford an open box. She has $50 to make the box. So let's make sure we understand what we boxed and didn't. We know what a box is. We know a square base. What's the difference between a closed box and an open box? That'd be a good question to start with. Does an open box have a lid on top? No. So a closed box has a lid? So how many bases does a closed box have? Good. In an open one? Just the one square base. Yes? Okay. So what's the big question? Her big question is she does not know if she can afford a closed or an open box. That's the big question that, as we do the math, we'll answer at the end. Okay? So, let's start with number one. Create 3 different size boxes with dimensions that have a volume of 32. For each box, find the amount of material needed to make the box. Remember, the base is a square. So, in order to understand this, I need to understand 2 parts. So first we're going to be talking about an open box. The second part, there's one here. So even though I need to be more specific here, create 3 different boxes with that. For each box, find the amount of material needed to make the open box. Will you need more material for the open box or for the closed box? The closed one. All right. So remember, the base is a square. So for me to understand the dimensions of the toy box, I need to start with what I'm given, which is the volume. Volume is length times width times height, and it must equal what number? So what I need you to do is tell me 3 dimensions that equal what number? But when you tell me the 3 numbers that multiply together to equal 32, 2 of the numbers have to be the same because it's a square base, yes? So before I tell you, you try. Think of one possible size of box. When you multiply it together, it equals 32. So think. And 2 numbers have to be the same. So, can anyone think of something that would fit those parameters? Davian? 2 times 2 times 8. You know what, Davian? I didn't even hear that. I know what number I kept hearing out loud for everyone to hear. But you know one I didn't hear? It was 2 times 2 times 8. Does that fit my box? Is 2 times 2 times 8, does that equal 32? Does that make a square base? Good. Okay. Marilyn, what was the other one I heard? 4 times 2. All right. I want you to do another one, but this time, you ready? And you're allowed to use a calculator. This time, I don't want it to be whole numbers. I want you to think, give me a dimension where it's not whole numbers. Can you think? That's the challenge. What are 3 numbers that multiply to 32, but not whole numbers? Can you meet the challenge? Not whole numbers. So the three numbers would be decimals. But you're allowed to use a calculator. Can you meet the challenge? Kaylin, can you meet the challenge? All right. Daniela, tell me what numbers you picked.
I got 8 times 8 times 0.5.
Okay, so 8 times 8 times 0.5. They're not all whole numbers, right? So that's a good one. Could you think of another one where they aren't all whole numbers? You don't have to use hers. That's a good one. So, let's say you understand it's a square base, right? You could do this, right? Can't you pick, within reason, what size of base could you pick, right? So obviously the base can't be, in terms of thinking through here, 16 times 16, and then point, like, really small, right? So let's do something more reasonable. Let's say that your base was 3.5, right? That would mean your next base would also have to be what? Or the size would have to be 3.5. What do you get is 49 over 4, or you can write that as 12.25. Because I know the volume is 32, how could I find the height of that box? Is to divide. So you could pick any two numbers, right? And then you'd have to round to try to figure out that, or you might have a nice number. So in this example, if I went 3.5 and 3.5, what would the other dimension have to be? 2.6. What happens if I went 2.5 times 2.5? What would I have to divide that number by to find the last one? So is there an infinite number of possibilities you could pick for the dimensions? So let's just say, I say, all right, I meet the challenge. 2.5 times 2.5 times 5.12. What I want to tell you is that it doesn't have to be a whole number. Yes? Most times in life, it's not going to be whole numbers. That's going to solve the big stuff that you're looking for. So as long as you know the base, you can use 32 and then find what the height would be. And you could create anything here, right? You pick the number, divide, and then you can find the height. Now the second question. How do you know how much material you need to make your box? So what we just did was the volume to understand. Surface area. Do you know how to draw a box? Do you know how to draw a box? Like a really nice box?
Oh, 3D.
A cube?
Well, it might be a cube. A cube is something where all the sides are the same length, right? We don't know if it's a cube, but we do know the base is square. So I'm drawing a picture of this so you can get a sense of, like, how would I find the amount of material I need? Do you know a box is made up of what's called faces? And if it's an open box, do you know how many faces are put together to make the box? Like a mime, right? So there are 4 around the side, and then the bottom. So the bottom base is a square. So if I just label that, that would be 2 times 2, which is 4, right? Then, do you know what each rectangle would be? So if the base is 2 and the height is 8, what size would be the rectangle? How do you find the area of a rectangle? It would be 2 times 8, which is, and then each rectangle, because it's a square base, all the rectangles are the same size. So how many rectangles do you have? So how much material do you need if these were the dimensions? It'd be 4 plus 64. 4 plus 64, which would be? So in this case, because we're doing inches, the amount of material you would need would be inches squared for area. Look at the next one I put down. How much material would you need for this box? So 4 times 4 is 16, and then each rectangle is going to be 4 times, each rectangle will be 4 times 2, and how many of those rectangles do we have? What answer do I get? 48. So they both have the same volume, but does it take the same amount of material? So what we're trying to do is find the least amount of material. Like, can we try it again with our calculator? So this one, you would take the base, which is 2.5 squared, and then you have 4 rectangles, and each rectangle is 2.5 times 5.12, that your dimensions do change the amount of material you need. Yes? So it matters what size your box is. If you have a size of box, you might need more material or less. So for the last one, it's 57.45. And what I wanted you to see is, does the size of the box matter for how much material you need? And what's our goal is to find the least amount of material. Does that mean my answer is here in the middle, because it's 48, that's the smallest number? Well, we can't just go by our gut and throwing numbers on the wall, right? We actually have to do the math and really see what dimensions would give us the least amount of material. Do you see the big picture of what we're looking for? What dimensions use the least amount of material and still have a volume of 32? All right, let's look at number 2. You ready, Pedro? Because I think you're looking at something else. You ready? All right. Write a formula for the volume of a box with a square base, x inches, and a height of h. So if you had a box, and your base is x, and your height is h, what would the volume of that box be? What's the volume of a box again? Length times. So using those variables, do you believe it's x squared times h? Is that the volume? X times h? Will the volume formula change if the box is closed or open? If you had a lid on it or no lid, would that change the volume? Why? Why would it not change? What doesn't change that matters for the volume? Do the dimensions of the box change whether you have a lid or not? And that's what affects the volume, correct? If you get behind and you need to take it this right, you can always watch the video, right, to fill in what you need to. But I know you want me to finish this, right? All right, number 3. Write a formula for the surface area of an open box with a square base x, inches long, and a height of h. So we have the same box, but now I want to know what the surface area would be, how much material I need. What would it be a formula to do for that? So how did I do that again? How did I find how much material I needed? Well, what shape is the base? And so what's the formula for a square? So it'd be x squared. And then each rectangle. Well, each rectangle has what dimension to it? X times h. And how many of those rectangles do I have? So does this describe the surface area? X squared and then 4 times xh. Will the surface area change if the box is closed or open? Yes. Why? You will need more material for a closed box. Why? So why will it change? Because a closed box, you need more material because now you have a lid. Yes? So does the volume change whether it's closed or open? Because the dimensions don't change, right? But do you need more material if you have a lid? Okay. So write a formula for the closed box. So this one is for the open. What would the formula, how would it change if it was closed? Something's going to change. What's going to change? So instead of 1x squared, we now have, for both the base and the lid, everything else would stay the same. Number 4. Using the volume formula, rewrite the equation solving for h. So the volume formula was x squared times h. How can I rewrite it to get h by itself? If I want h by itself, what's the inverse of multiplying? So I could divide both sides by what? So h is equal to the volume divided by x squared. Didn't I do that for the calculator? You know how I found the base and I wanted to find the height? So I used my calculator and this is what I did, divide. Now substitute in the surface area for an open box. Now, do I know what the volume is? What's the volume of my box? Yes, I do. What is it? So what is h equal then? Is 32 over x squared. So now substitute into the surface area formula for an open box. So you remember the one for the open box? So where there's an h, what am I going to put in now for h? See, what I did, which is so important, is now I only have how many variables on the right side? Do I only have one? Can I now use a graphing calculator or calculate it easier because I have one variable, right? That I'm looking at, not two variables, but one. So I used the volume formula, so I could use one formula, one variable. All right, turn the page over. It says, using Desmos, I want you to graph the surface area formula. Remember the one we just came up with? By the way, what type of equation is this? Rational, right? That's right. So can you use on your phone? I'll do it on the screen through my computer. Can you get Desmos up? Or you can use your graphing calculator. But for this one, I just want it to be easy for you. And Desmos is easier. But on the SAT, you can't use Desmos. So simply, can you type in x squared and then plus 4x parentheses and then a fraction and then put in 32 divided by x squared. See what, after we type it in, we're not over, right? The answer is not magically just going to hit you in the face. You need to know how to manipulate and know what to look off the graph. So it says, what are you looking for on the graph that will give you the answer you're looking for? I want to know what dimensions will give you the least amount of what? Material. Do you know what the word least means mathematically that you've heard before? You're looking for the minimum, right? So when I look here, do you see this red line, first of all? This is not helpful because all the x values for this is what? Negative. Do we want a negative side length for our box? This, I'm done. I'm going to move the graph over. I am only looking at positive numbers. And if you don't see the picture, it's because you're too zoomed in. You got to zoom out. Can you do that for me? So first of all, I'm going to move the graph over. I don't need to look at negative numbers. I don't see a picture. So what should I do? If I zoom out, keep moving the graph over. I don't see anything. Zoom out. Oh, I see something. So once you see what you're looking for, can you zoom in on what I'm looking at? I'm not looking at the negative numbers. Do you see, and with Desmos it's pretty simple, can you see what X value gives you the least amount of material? Now, all of these are examples of the box. Any of these could be the size of the box, but we want the box with the least amount of material. How did I use the graphing calculator to find my answer? So what's the least amount of material that we need? 48. What does 4 represent then? 4 is x, and x was my base. So what should my base be? 4 by 4. Could I then find the height? And then do I have my answer, right? In terms of the size of the box. So the question was, what are you looking for? So, were you looking for the relative minimum point for positive x values, right? You weren't looking at the negative x's, but for the positive x's, you're looking for the relative minimum, the low point. So, write down the point on the graph that will help you. What was the point that I found that's going to help me? 4 and 48. All right, let's continue. What is the least amount of material you need to build the box? The least amount of material is 48 inches squared. And that came off the graph, not my gut, right, using math? What are the dimensions of your open toy box? Well, they're 4 feet by, inches or feet? Inches. 4 inches by 4 inches, because that's what x is. How do you find the height of your box? Do you remember what height equaled? Height equaled 32 divided by, remember this right here? 32 divided by, do you now know x? So what's 32 divided by 4 squared? That's 32 divided by 16, which equals 2. So what should your box be, the size of it be? 4 inches by 4 inches by 2 inches. What did that create? We're not looking at maximum volume, but the least amount of material that still holds that amount of stuff I need. So how much material, how much will it cost to make the box if it costs 75 cents per inch squared? Well, how much material do I need? How much does it cost? Well, let's go. 48 times 75 cents. How much will it cost? And the cost of the box would be $36. Does Kate have enough? Look at the front page. How much money does she have? Last part. Using Desmos, can you graph the closed toy box surface area equation? Wait, where is that one? Do you remember the closed one? What was the closed one? But I'm not going to use H. What am I going to plug in again for H? So, it's the same one. So when I go back to Desmos, the only thing I need to change is what? 2. Would you think you need more material or less? You have a lid, right? You're probably going to need more. So when I go back, all I got to do is make the x squared a what? 2. What happened? Our minimum is still minimum, but now it's a little higher up, right? Do I need more material? Okay, so now tell me, what is the least amount of material you need to make a closed box? 60.476, right? What are the dimensions of it? What's the base? 3.175, and then the other side is 3.175. Do you remember how to find the height again? What do I have to do with my calculator to find the height? So I got to plug in 3.175. Now we're just going to round this one because it's irrational. So I'm going to round it to 3 decimal places. But guess what it ends up being if you round it to 3 decimal places? Nancy said this before, this word. What is it? 3.175 by 3.175 by 3.175. We call that a cube. You don't remember saying that word?
No.
You didn't say it? Did anyone hear Nancy say the word cube? Thank you. I remember what you say. So, guess what? When it's an open box, open, is it a cube? Is that a cube? No. But when it's a closed box, it's a cube. Does Kate have enough money to build a one with a lid on it? Well, how much is the surface area again? 60.476. How much does it cost? 75 cents per square foot. Can you use your calculator? Do you have enough money to build a closed box? How much money would it take to build a closed box? Hey, you just finished the project. The question was, remember a big question? She does not know if she can afford a closed box or only afford an open box. Did we answer it? And she has enough money for both. Did we use her gut or some math? Mr. G, math. Over and out.